Hello, everybody. It's Miss Wiley here, and I am going to give you guys a little lesson. I hope you enjoy this video lesson. This one is going to be on multiplying polynomials. Now, I know that we have already talked about multiplying polynomials, but so far in class, we only discussed multiplying binomial times another binomial. And we talked about problems like this. If you had like 2x plus 1 times x minus 3, so 2 terms times 2 more terms. And we talked about how that will always get you 4 terms, right? So the method that we discussed in doing this was the multiple distribution method, which has a fun mnemonic device called FOIL, right? Remember FOIL, where F stands for first, O stands for outside, I stands for inside, and L stands for last. Now, you don't need to use that mnemonic device, but it is there to help you if you need it. The F in the problem stands for multiplying the first terms together in both of the binomials. Now, remember, when you multiply, you're going to make sure to take into consideration those missing exponents of 1, so that when you multiply variables, you add your exponents. You do not need to put those ones there if you don't want them. So multiplying one term times another term, here we're going to get 2x squared. Let me put my equal sign there. 2x squared, right? 2x times x. From there, you're going to go ahead and I'm going to pick a different color here. And we're going to take that term, 2x, and we're also going to multiply it to the other term in this binomial. Okay, so that is the outside terms of the binomial. That's what the O stands for. So doing 2x times negative 3, you don't forget to pay attention to your signs here. You get negative 6x. Okay, next on the list, we have the I. I stands for the inside, right? The inside terms of the binomials. But that's what you would do anyways, because you've already distributed this to those two terms in the second binomial. So now you got to distribute this bad boy into the second binomial. So 1 times x. That's your inside. That's what the I stands for, right? So we have the I inside. 1 times x would be, well, positive 1x. And then from there, you're going to go ahead and do the last. The last means taking this 1 times the negative 3. That's where the L comes into play. They are the last terms of the two binomials. So the last terms are 1 times negative 3. That's going to give you negative 3. So there you have it. You have your 4 terms. But now remember, anytime you are doing these problems, there are 2 things that you need to remember to do. You need to remember to combine like terms. And like terms are terms with the same variables and same exponents. We also need to take into consideration standard form. Standard form is putting your exponents in order, biggest to smallest. So when I go to combine like terms, I like to make sure to combine the highest exponent terms first, and then and sort of go down from there, right? So let's go ahead and do that. So the highest exponent term is 2x squared. There are no like terms with this, right? There's nothing to combine with that term, so I'm just going to bring it down to the next step. Then you have the negative 6x and the 1x. Those are like terms because they both have an x, technically an x to the first power, but you don't have to write that exponent of 1. When you combine like terms, you combine your coefficients and keep everything else the same. So negative 6x plus 1x would be negative 5x. So those are like terms, right? You'll see I'm marking things as I go along. I like to do that to make sure that I've taken all of my terms in this first step into consideration as I go on to my second step, or my simplifying step of the problem. The last thing here is we have a constant value. A constant value is a value with no variable at all. There are no other constant values, so I'm just going to bring it down to my next step, and then this is your final answer. All like terms have been combined, and you can see my exponents go biggest to smallest, and you are done with the problem. Let's take this to the next level here. The next level would be doing something like a binomial times a trinomial. We can also consider trinomials times trinomials or trinomials times binomials. All of these go into effect here, right? And so for this, think of it as I'm going to have two terms that I'm going to multiply to three terms. So how many terms do you think you will get here, right? You would get 6 terms. So let me show you why that is. So let's look at an example here together. An example would be something like x plus 5 times the trinomial x squared minus 3x plus 2. Let's do minus 2, right? Minus 2. Okay. So there we go. The idea when multiplying polynomials here is that you want to make sure that everything in the first polynomial gets multiplied to everything in the second polynomial. So that's why we have to distribute twice. We're going to first distribute this to the second polynomial, and we're then going to distribute this to the second polynomial. And that will give us our 6 terms that we're looking for. So let's start with this first term, x. We're going to multiply it to all 3 terms here, right? Taking that, we have x times x squared. Remember, keep the variable, add your exponents. 1 plus 2 is 3, so it's x to the third power, or x cubed. Then we're going to take x and multiply it to negative 3x. That's negative 3x squared. Now remember, x times x, always x squared. It's always good to kind of just be quick with that. Then we have x times negative 2. That's going to be negative 2x. Now that's what we get as we distribute that first term to all the terms in the second binomial. So now let's switch it to the second term in our first binomial, which is 5. And we're going to multiply that to every term in the second binomial, just like we did with the x. So taking this one term at a time, 5 times x squared is going to be 5x squared. 5 times negative 3x is going to be negative 15x. 5 times negative 2 is going to be negative 10. Now here you go. There are your 6 terms that I talked about over here, right? So we got 6 terms total, but we're not done because we still need to combine like terms and make sure it's in standard form. So as I go to combine like terms, I'm going to start with my highest exponent because I want that to be first. So my highest exponent in this whole problem is an exponent of 3. There are no terms to combine with x to the third power, so I'm just going to bring it down in my next step. The next exponent would be x squared. So, well, that would be this, and that would be this. Combining negative 3x squared and 5x squared is going to give me a positive 2x squared. Do not change your exponents when you're combining like terms. The next thing that we have here is we have a negative 2x and a negative 15x. And combining those two, I have a negative 17x. When you add 2 negatives, you get a negative. And then finally, last but not least, you have a constant value. In our constant value, nothing to combine with it. And we have a negative 10. And you can also see that I've taken all these terms into consideration because I'm sort of marking them as I go along. If you want to sort of just put like, oh, I dealt with that one, I dealt with that one, okay, I dealt with the, do little check marks to make sure that you've taken all of them into consideration. That's something else that you could definitely do when making sure that you take all the terms into consideration when simplifying. So this is our final answer. Our final answer is all 4 of these terms. Now remember, initially we had 6 terms, but it can always simplify to less terms. The last sort of situation that we have here possibly is if we did a trinomial times a trinomial. Now, I'm not going to go through an example like this, but imagine if you had a trinomial times a trinomial, what would have to happen, right? So a trinomial times a trinomial would be something like x squared plus 5x minus 1 times x squared minus 3x plus 2, right? So that's sort of what it would look like, right? And then when you do a problem like this, it's the idea that you would have to distribute this to all three terms. It gets sort of messy here. Then you'd have to distribute this to all three terms. And then this is where it gets really crazy. You have to distribute this to all three terms, right? And you don't have to draw the arrows. The arrows are there to sort of help you and guide you, but it's not necessary. Now imagine if you were to multiply, 3 terms times 3 terms. How many terms do you think you would get? Right? You would get 9 terms. Hopefully that's what you were thinking, or maybe even answering out loud as I'm talking to you. So I hope that this will help you multiplying polynomials. It's a little bit of review of what we have done before with the FOIL method, and then adding on to it with just bigger polynomials, but the same approach of multiple distribution. Okay, so please refer to these notes as much as you need to, and good luck with your practice on this.